Hey everyone, this is Delta Penguin again from PengTech, name subject to change. But yeah, so we're talking a little bit about the power of the computer and why you want to use it. Why do you want to use it in general, and what good, um, how computers, what computers do best, and what humans do best in a sense. Computers are very good at calculating things very quickly, but not really for thinking on its own, thinking for itself. It can run the commands really quick, but you have to tell it. It needs like a human to tell it what kind of commands to do, in what order, how to run it, things like that. It can't really infer things, generally speaking. So let's say, let's go back and give some examples to back to the calculator program. Okay, and I'll get this notepad here as a, let's see, as a way to write some stuff down. So the computers, right? Let's think. Computers are a bit tricky to explain because, like what's happening is behind the scenes is what we care about. But computers are processing, everything in its hardware. It's using electricity and electric pulses to manage things. But we can't, it's all happening at a microscopic level. We can't really just see it with our naked eye. And we have to sort of like imagine and envision and sort of like try to, imagine what's going on basically. So let's break it down. So this is a computer program, right? The calculator. So it's nothing too complicated. But what do we have here? It's basically, again, there's buttons, there's like a series of operations you can do, and then it looks like it gives us our result back when we hit the equal sign, right? So like, 8 times 3 is equal to 24. Okay, yep, and it's right, 24. So like what is happening here? Again, someone had to code and design this, even though, it makes sense to us that, hey, if you press the button that says 8, right, it should put 8 on the screen, right? That just, it makes sense that we infer it, but it required someone to write that code for it to actually happen, for the computer to actually be able to process that data and sort of know, like, how does it know what to calculate? When I press 8x2, how does it know that the result should be 16, and to use these numbers? That's where variables come in to play. Okay, so again, you sort of have to imagine, okay, this is the digital world. Somewhere behind the scenes, this is what we see, but what we can't see is the computer is thinking really hard behind the scenes. Okay, and so with a program like this, it's like, okay, for a simple calculator, what's going on in the calculation of 8 times 2? It's, takes one number, it does something to it with another number, some kind of operation, right? And then you get a result back. So let's see if we can try to write that down. Write down what's going on. So it's basically calculator program. Calculator program. It says takes one number, does some operation on a second number, and then returns or gives us back some result, right? Some value. Okay, that's straightforward enough, but how does it do that? In order to do that, it has to store some of this data in its memory. Like when you type in a number, it has to remember, okay, I need to hold on to that number so that I can calculate it later. How does it do that? It does that through variables. So it's basically what it is in code terms. Okay, and coding is, to go back some, so the computer understands like a different language than humans. So it's kind of like, one person speaking English and another person speaking French, right? It's like they can talk to each other, but they don't really understand each other. In order to understand each other, you need someone to translate and convert one language to another. Programming is basically that. code is a list of commands that we write in some kind of programming language, again, like C++, C#, and that is used to, and that is kind of like a human, that's like an English-like language, which is used and which is then translated into computer language. So like, as an example, computer language technically is all just ones and zeros. So it's like something like this, what seems like a random bunch of just different numbers. But behind the scenes, the computer is able to take, say, like, take some of these letters or some of these numbers, like, and then translate, like, okay, these eight numbers, I can translate that to like the letter R, and then maybe this, eight-ish numbers, becomes like the letter E or something like that. So it's just a huge string, and then the computer knows how to like translate that over. It doesn't look readable to us, but again, since the computer can calculate like 1 million calculations a second or so, it can, read all this and then bloop, spit out something else like this text or something like that. Okay, so that's kind of what's going on behind the scenes when we write code in a programming language. It's English-like. So as an example, so up above is kind of like pseudocode. It's kind of like, it's like a description of what the program is doing. And then, so I'll write something that's code-like, maybe not exact, but just for, our educational purposes. So let's say it's something like, we need to take two numbers and do something to them. For simplicity, we'll just add them to start. But to do that, the program, so the computer, the set of computer code that is this program needs to hold some number data. Okay, so that means we need a variable that can hold number data. So let's say something like, let variable 1 equal to some data. So, okay, the number 8. Okay, and then, so let variable 2 is equal to 2. Okay, and I'm going to change this to plus instead, 8 plus 2. We'll keep it simple to start. 8 plus 2 is 10. So if we do that, then we expect some operation happens. So variable 1 plus variable 2 should be equal to 10, right? The result. And then maybe we want to store the result too. So we'll create a variable result. And this is just the name. Basically, it's a digital container. It's just the name of the container. You don't have to type var beforehand. I'm just using it as an example and to make it kind of clearish. Okay, so we want this value to go here. So in computer programming terms, when you have this equal sign, this is to assign the value to the thing on the left. So 8 is being assigned to var1 container, and 2 is being assigned to the var2 container. And then results, we'll say it starts at 0. Okay, so we want to perform some operation, which will give us the value of 10. And we want to put it in the result. So we want to put it in the result container. So this is how you would write it in code. So it's kind of, again, it's English-like, but then some other program will take this and then translate it to the ones and zeros that the computer needs in order to understand it. Okay. So basically var1 plus var2 equals the result. Or to make it clear, you could, you could rename it something like var number 1 and var number 2, because then it's a little more obvious. Okay, what does this container hold? It holds number data. Okay, and to give you a practical-ish picture. So again, the digital world is, you sort of have to imagine it because you can't just see it directly, right? We're not directly seeing the electrons and electricities move around in order to store that data and perform those operations. So let's just imagine, okay, when I say, when I say var1, or when I say that, I'm basically saying, hey, create for me a digital container called var1. So it's like a box, and you're putting a label on it. This is now my var1 container. And then when I say, okay, var2, whoop, poof, out of nowhere, now I have a digital container for var2. What numbers did I give it again? Give me a second. It was 8 and 2. Okay, I'll change that. 8 and 2. Okay, give me a second. Let me get some props. All right. So this is saying digitally create a container number, var num1. So I changed the name a little bit. Okay, 8 and then 2. So what does that look like? If we were pretending this is like the digital world. This is the digital world now. Okay, let's see. Okay, the digital world. So I created a couple containers. Got var1, got var2, and then I say, var1 equal to 8. What I'm saying is, hey, here's some number data, 8. Nothing's in it right now, but I want you to store this number 8. I'm going to need it later. So, all right, var1 has the number 8 in it. And then poof, I create another container called var2, and I want it to also hold number data. And here, I'm going to need this later, okay? So, all right, nothing in it currently. Sticking number 2 in it. All right, cool. So this is like creating the containers, and these are called you're creating the containers, and now I want to give this data to the program, and the program, I want it to add them together. So that's the operation. I'm keeping it simple. So, okay, whatever's in var1, whatever's in var2, I want you to add, I want you to add that together, computer. So the computer, okay, so I give it over. Oops, sorry. I give it over. The computer's like, okay, let me see. I got 2 from var2, and I have the number 8 from the var1 container. So it goes, okay, let me think about it. Poof, here's your answer, number 10. And then, okay. And then it sticks it into the var result container, which I don't have at the moment, but then it stores it there for later. Okay. So that's basically what's going on behind the scenes, except for the computer can do it like that, right? Whether it's a simple operation like that, or whether it's 62 times 5,402 or something like that. It can just, very quickly, very easily calculate it, but it can only do it if it knows what numbers to work with, right? So to do that, we have to create the numbers, put it in a container, and then give it to the program to process it. So that is the gist of what a variable is and where we would use it in programming.